Lesson 1, and it's Coulomb's law calculations. But before we start, I'm going to go to page 46 and we'll look at some new information we have. So the charge on the electron, which we've already used for changing electron volts to joules, is now going to be very important. So the charge of the electron, 1.6 by 10 to the minus 19 coulombs. It's there for you. Now remember, the charge on the electron, the size of the charge of the electron is the same as the size of the charge of the proton. Okay, so that is also the charge on the proton. Will be very important as we go on. And on page 47, also very important, is the permittivity of free space, epsilon. Now that constant is in Coulomb's law, 1 over 4 pi epsilon, and this is for free space. Okay, so this is nothing. We'll see in a minute how we deal with situations which are not free space, but that's the formula there. So it's 8.9 by 10 to the minus 12, effectively, to 1 decimal place. Okay, so page 46, 47, we need to know those. And if we go back to page 45, we're going to need to know our prefixes again and know how to find them. Okay, because we're going to come across some of these. Okay, and we'll see as we go along. Okay, right, pico is 10 to the minus 12. We'll be dealing with pico as we go today. Okay, so question 1. Okay, calculate the force between two electrons that are placed 5 micrometers apart. Okay, all right, so let's go through what we have. We're asked for the force, so we make our list. We don't know our force. Okay, 2 electrons, so they're placed 5 micrometers apart. So our distance between them is 5 micro. So from page 45, that's 10 to the minus 6 meters. We might as well change that straight away. And the charge, Q, is the charge on the electron, okay, which again we have from our tables, and 1.6 by 10 to the minus 19. Now I'm quite happy here going to 1 decimal place because they've given us to 0 decimal places. Okay. Now also remember, permittivity is free space, and we presume it's free space because we weren't taught otherwise. 8.9 by 10 to the minus 12. Okay. It's clearly a Coulomb's law question because it's force between charges. So we write down a formula. Okay, and we fill it in. So 4 pi 8.9 by 10 to the minus 12, 1.6 by 10 to the minus 19, multiply by itself, so just square that, and d squared, the distance between them, 5 by 10 to the minus 6 squared. Okay, and I end up with a value of 9.2 by 10 to the minus 18 newtons, which is a tiny force. But remember, electrons have a tiny charge, and 5 micrometers is actually quite a large distance. They are far apart, tiny charge, tiny force. Okay, but it's just applying Coulomb's law. But we have to remember charge. When we see electrons, we know the charge of the electron, okay, and we know the permittivity from pages 46 and 47. Okay, question 2. Right, so let's look at it. Electron is 53 picometers. Now we don't know what pico is, but we go to page 45 and we've just looked at it. So our distance now is 53 by 10 to the minus 12 meters. Now note, much closer, a million times closer effectively than question 1, so we expect a larger force. Now it's from a proton, an electron to a proton. So the charge of Q1 is the charge of the electron, which is 1.6 by 10 to the minus 19. Now this is the tricky part. The charge Q2 is also the charge of the electron because the charge of the proton is the same. Opposite direction, and we should have done it earlier, okay, in the previous question. Okay, the force was repulsive. Two negative charges, they repel, so you should have said it was a repulsive force. So go back and fix that. So an electron is 53 picometers. Okay, so this 1 is plus, 1 is minus. We ignore that until the end, and we use our like charges repel, unlike charges attract to decide is a repulsive or attractive at the end. We don't bother putting in minuses in the calculation. I think it's the easiest way of doing it. Okay, so we're asked for the force. Again, it's Coulomb's law. We weren't told there was anything other than free space, so we put this in. Okay, that's your information. So we go to 1 over 4 pi epsilon, Q1, Q2 over d squared from your tables. And in this case, once again, on the top, we have the charge on the electron, multiplied by the charge on the proton, but they are equal charges, so we can square them. 4 by pi, 8.9 by 10 to the minus 12. It's very similar to the other question, except that the distance is much closer. So we expect a larger force, and a much larger force because it's an inverse square law. And when we do it, we get a value of 8.1 by 10 to the minus 8, which is a factor of 10 to the power of 10 greater, which is 10,000 million times greater force. It's a lot greater. Still a small force, but that's the force between an electron and a proton in a hydrogen atom. Okay, that's on average the distance they are apart. Okay, so again, just using, writing down everything we have, recognizing it must be Coulomb's law, knowing that we have permittivity, and very important here, the charge on the electron is the same as the charge on the proton. If we were asked for a charge on an alpha particle, we know it's twice that, because we know the charge on the alpha particle is plus 2. Okay, so we can get the charge of anything that is a multiple of the charge on the electron, because on page 46 we're given the charge on the electron. Okay, question 3. Right, a little bit of a variety here in that you're given the force this time. So let's have a look. We're given the force. So force is 8.2 millinewtons. So 8.2 by 10 to the minus 3 newtons, using the prefix for milli. Two identical charges. So Q1 is equal to Q2. Okay, and we don't know what it is. 4 millimeters apart, so distance quite far apart, in fact. Okay, 10 to the minus 3. Now, a relative permittivity of 1.5. Now, this catches people out. When you see relative permittivity, that means how many times the permittivity of free space it is. So it's clearly not 1.5. So to get the actual permittivity, we multiply the relative permittivity by 8.9 by 10 to the minus 12. So relative permittivity just means, that it is that many times the permittivity. Okay, so we multiply that. So 1.5 multiplied by 8.9 exponential minus 12, and we get a value of 1.535 by 10 to the minus 11. So we would say 1.54 by 10 to the minus 11, and that's the permittivity we're going to use. Okay, so we go to our formula. Again, it's clearly, hopefully, Coulomb's law, because it is the force between two charges. So this time we have the force, so we fill that in. Q1, Q2, they are the same. We don't know what they are, so we'll just call them Q, and we'll say Q squared. 4 by pi, now, that's now 1.54 by 10 to the minus 11, by distance squared, which is 4 by 10 to the minus 3 squared. Okay, to get Q squared, hopefully it's pretty clear, we're going to multiply 8.2 by 10 to the minus 3 by that. Okay, so we've 8.2 minus 3 multiplied by 4, multiplied by pi, multiplied by 1.54 exponential minus 11. Okay, multiplied by 4 exponential minus 3 to be squared. And we end up with this value, 2.53 by 10 to the minus 17. I'll just go directly from there and get the square root of that. Okay, and we get a value of 5.03, so since we're kind of going to one decimal, we'll leave it at 5.0 by 10 to the minus 9, and the unit for charge is the Coulomb. Okay, and that is that. Very good.